Hello, this is Sal. In today's video, we will be talking about configuring basic RIP version 2. RIP version 2 is used for routing of IP version 4 addresses in small networks. RIP version 2 is a classless distance vector routing protocol, as defined by RFC 1723, is a classless routing protocol. Subnet masks are included in the routing updates. By default, RIP version 2 automatically summarizes networks at major network boundaries. When automatic summarization has been disabled, RIP version 2 no longer summarizes networks to their classful at boundary routers. On the description of this video, you will find two files, one for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configuration you did during this lab. If you like my videos, please subscribe to my channel and recommend it to your friends and share it and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. In today's lab, we will configure the network topology with RIP version 2 routing, disable automatic summarization, propagate a default route, and use CLI commands to display and verify RIP routing information. Here there is nothing is configured on this network, so I will start by configuring the routers, starting with router 1. Enable configure terminal hostname router 1, interface gig01, IP address of 172.16.10.1 with /24 subnet mask, and enable the port with no shut. The interface of serial 00, IP address of 10.1.1.1/30 subnet mask. Enable the port. Now on router 2, enable configure terminal hostname router 2, interface serial 000, IP address of 10.1.1.2/30 subnet mask. Enable the port, and the other interface serial 001, IP address of 10.2.2.2/30 subnet mask. Enable the port, and the other interface of gig00, IP address of 209.165.200.1/24 subnet mask, and enable the port with no shut. Now on router 3, enable configure terminal hostname router 3, interface serial 001, IP address of 10.2.2.1/30 subnet mask, no shut. And the other interface on gig01, IP address of 172.16.30.1 with /24 subnet mask. Now, the PCs here, we have PCA, PCC, and PCB here, which represent, in this lab, the internet. I configured already the IP addresses, and here for PCA, on the IP configuration, sorry about that, desktop IP configuration, this is the IP address for router PCA. Now, until now, or so far, the PCs are not able to ping each other at this point. So let's try to ping from PCA to PCB. PCA here, ping 209.165.200.2 is saying unreachable, but the PC will be able to ping its own gateway. 10.1. And the same goes with PCC. It will not be able to ping PCA or PCB at this point. Ping 209.165.200.2, it's unreachable. It can only ping its own default gateway. This is for PCC, ping 172.16.30.3. Sorry, .1, it's gateway. Next, I will configure and verify RIP version 2 routing in the network. Then, I will verify that the routing tables are updated correctly. After that, I will disable automatic summarization and then configure a default route and then verify end-to-end connectivity. Now I will start with router 1. I will configure RIP version 2 as the routing protocol and advertise the appropriate connected network. So here on router 1, router for today's lab, which is RIP, and we are going to work with version 2. So now we have the passive interface on gig 01, which is this LAN here, this interface. This is a passive interface. Now I will configure a classful network, like for the IP address 10.1.1.1/30. This is a class A, and this is 172.16.10, and this is a class B. So in the network, we will configure the classful network of 10.0.0.0. This is class A, and class B 172.16.0.0. Now let me ask a question here. What is the passive interface command? This command stops routing updates out of the specified interface. This process prevents unnecessary routing traffic on the LAN. However, the network that the specified interface belongs to is still advertised in routing updates that are sent out across other interfaces. Now, next, I will configure RIP version 2 on router 3 and use the network statements to add the appropriate connected networks and prevent routing updates on the LAN interface. We did this on router 1, so let's do the same on router 3. Exit router, which is RIP version 2, and we want the passive interface also on gig 01. Now again, we will configure classful networks for class A, class A, class B, class B. Here we have the network of 10.0.0.0 class A, network 172.16.0.0 class B for this LAN here. So we are done configuring router 1 and router 2, RIP version 2 on these two routers. And we configured the interfaces on gig 01 and gig 01 here on router 1 and router 3 as passive interfaces. And we configured a classful networks. Now on router 2, I will configure RIP version 2 and use the network statements to add the appropriate connected networks. I will not advertise this LAN here on 209.165.200.0 network. It's not necessary to make the gig 00 here interface passive on router 2 because the network associated with this interface is not being advertised. So here on router 2, router RIP version 2, we will not configure the interface of gig 00 as passive interface, but we will configure the classful network of 10.0.0.0 for both interfaces on this side, on serial 000 and on serial 001. Enter. Now it's time to examine the current state of the network, as the status of the two serial links can quickly be verified using the show command. Here, back to router 2, I'll use this show command to show you the two serial links. Show IP interface brief. Here showing us on the serial 00, this interface here with this IP address, and it is up, and the same with this interface here on serial 001. Now let's check connectivity between the PCs. I'm not sure for now because packet tracer have this bug, so if we encounter this error, so I will clear it and fix it. But PCA should not be able at this point be able to ping PCB or PCC. So on PCA, let's try to ping PCB, and it's telling us it's unreachable, which is correct, but we have a bug, with packet tracer. So also I'll try to ping PCC on 172.16.30.3. Now it's telling us it's receiving a reply, which it shouldn't at this point. So I'll go to router 1, and I will use this command to clear the IP route table. And here, clear IP route asterisk. So now show IP protocol. Here, as you can see, it's showing us we are using this RIP as a routing protocol. And here it's telling us about the two networks, which is doing the routing for. So show IP route. And here it is, this is on router 1. And I will run the ping again to from PCA to PCC, and now it is telling us unreachable. This is the bug I was talking about. The same with PCC, it should not be able to ping PCB or PCA because we for the LANs here, it is we did not advertise for them, or we configured them as we did not advertise this LAN. And here, this is a passive interface. So on PCC, try to ping PC A 10.3, ping 172.16.10.3. And the request is timed out, which is correct. Cancel and try to ping PCB on 209.165.200.2, and it's telling us it's unreachable. Let's go back to PCA and confirm that PCA it will not be able to ping PCC. So ping 172.16.30.3, and it's now doing the right work, or as it should. Now, on router 2, I will run this command, show IP route. Show IP route. Here, as you can see, the equal cost load balancing for the two networks. This is for this network here, and this is for the two networks. Now on router 3, also I'll run this command, and here, show IP route. Router 3 here, as you can see, does not have route to the remote LAN network on router 1. It has only for its own LAN. On router 2, I'll run this command again, show IP route on router 2. The network showing, just let's notice the networks are showing the connected one here is 10.1.1, this network here, and the other directly connected network on this side, and it is routing for the two networks here with the classful address. Now on router 1, also I'll run this command, show IP route. Show IP route. Notice the routing protocol and version. Now I'll verify that RIPv2 is running on the router. I will use debug IP rip also, and show IP protocols, and show run commands to confirm that RIPv2 is running. On router 1, I will run the command show IP protocol. Here, as you can see on router 1, it is showing the directly connected network, this network here, and it is routing for this network here, and it's advertising for its directly connected network on 172.16.10.0, but it is not showing the LAN by router 3. So now I will run the command show IP protocols on router 1. Now the routing protocol here is RIP and it's routing for the networks of 10.0.0.0 classful IP address and for 172.16.0.0. I will run the same command on router 2, which is and router 3, which is show IP protocols. It's again, the routing protocol is RIP and sending and the passive interfaces. And send version 2, receive also version 2, and default version control, and on the serial 000 and 001, and the passive interfaces, routing information source, the gateway, the distance, and the last update. This is by seconds here. Now I will run this command on router 3, show run or show running config. What is telling us about RIP? It's using RIP version 2 and the passive interface, which is this interface on gig 01, and it is advertising, for network 10.0.0.0 and 172.16.0.0. As I said, the show running config, the one we ran on router 3, this command, it provided us with the routing protocol, the version, and which interface is being configured as passive and the networks on router. Next, I will examine the automatic summarization of routers. As we can see in the topology that the LANs connected to router 1 here and router 3 are composed of discontinuous networks. Router 2 displays two equal coast paths to the 172.16.0.0/16 network in the routing table. Router 2 displays only the major classful networks addresses of 172.16.0.0, and it does not display any of the subnet for this network. So on router 2, when I run the show IP route here, show IP route. Notice the two networks on serial 000 and on serial 001. Yeah. Now, router 1 displays only its own subnet for the 172.16.10.0/24 network, and it does not have a route for the 172.16.30.0/24 subnet on router 3. So here on router 1, show IP route. Here it's just for its own LAN here, and we don't see anything for 172.16.30.0/24 on the routing table on router 1. And the same on router 3. Router 3 will be only displaying on its own subnet for the 172.16.30.0/24. So IP route, it is showing its own LAN. And we cannot see anything here for this network, the LAN on router 1 of 172.16.10.0/24. Next, I will use debug IP route command on router 2 to determine the rules received in the RIP updates from router 3. So go back to router 2 here and run the command debug IP RIP. I'll let it just, and how to stop it, you all, or here as you can see, it's sending and receiving. Sending version 2 updates on the serial of 0001 and receiving on the serial 000 for this via 000 in 1 hops. Now, router 3 is not sending any of the 172.16.0.0 subnets, only the summarized route of 172.16.0.0/16, including the subnet mask. Therefore, the routing tables on router 1 and router 2 do not display the 172.16.0.0 subnets on router 3. Now what I'm going to do is disable automatic summarization. The no auto summary command is used to turn off automatic summarization in RIP version 2. I will disable auto summarization on all routers. The routers will no longer summarize the routes at major classful network boundaries. So here on router 1, configure terminal, router RIP, no auto summary. Next, I will issue the clear IP route command to clear the routing table on router 1. So I'll do this clear. Exit, clear IP route. Exit, clear IP route. And I will do the same on router 2. Configure terminal, router RIP, no auto sorry about that, router RIP, no auto summary. Exit. exit from here and exit from here, and I will also clear the routing table, clear IP route start. I'll do the same on router 3. Configure terminal, router rep, no auto summary, clear IP route. Next, let us examine the routing tables on the routers. The LAN subnets connected to router 1 and router 3 should now be included in all three routing tables. Before, when we configured the classful and the auto summarization was not disabled, we were not able, when we run the show IP route on router 1 or router 3, to see this LAN or from router 1 or to see this LAN from router 3. So now I will run this command on router 1, show IP route. As you can see here, the directly connected, which is this network here, and it is routing for, this is for rep for 10.2.2.0/30, this network here, and it is connected to this LAN of 172.16.10.0, and also it can see this LAN here, but we did not advertise for the LAN on router 2. Now with the no auto summary command, we are able to see the LAN here, as long as also we see the one here connected directly to the router. But because we did not advertise for this LAN on router 2, so we are not able to see it here now on the routing table on router 1. So now on router 1, the routing table contains all the networks except for the LAN on router 2 because we did not advertise for that. So now on router 3, I'll run the same command, show IP route. As you can see here, I'll expand this a little bit. The routing table on router 3 contains all the networks except for the LAN on router 2 because we did not advertise for it. Next, I will use the command debug IP route on router 2 to examine the RIP updates. So on router 2 here, debug IP debug IP rep. Now here, let's notice the routes and rep updates that are received from router 3, which is the LAN on router 3. And also let's notice that the subnet masks are included in the updates for sending and receiving. So let us leave it to run, and I will stop with U or run debug all. Next, I will configure and redistribute a default route for the internet access, which we said this line here represents the internet. From router 2, I will create a static route to network 0.0.0.0 with a subnet mask 0.0.0.0, which means any network with any subnet mask using the IP route command. This forwards any traffic with an unknown destination address to PCB at 209.168.200.2 simulating the internet by setting a gateway of last resort on router 2. So on router 2 here, router rep, sorry about that, configure terminal router rep, and now default, sorry about that, exit IP route to any network with this subnet mask, and this is the gateway, last resort gateway with 209.165.200.2. Here, router 2, after we configure this command, router 2 will advertise a route to the other routers if the default information originate is added to its RIP configuration. So it's still on router 2, configuring RIP, router RIP, default information originate. Now on router 1, I will type this command, show IP route. Let's study this routing table. How can we tell from the routing table that the subnetted network shared by router 1 and router 3 has a pathway for internet traffic with on router 2? We notice that there is a gateway of last resort, and the default route shows up in the table as being learned by a RIP. Here. Let us move next to view the routing table on router 2. Exit. Exit. Show IP route. How is the pathway for internet traffic provided in its routing table? Router 2 here has a default static route to 0.0.0 via 209.165.200.2, which is directly connected to gigabit Ethernet 0/0. And let's verify connectivity by pinging from PCA to PCC. So now on PCA, I will ping 209.165.200.2, 209.165.200.2. It should be successful. And it is. Now from PCC, also I will ping PCB, ping 209.165.200.2. Also this should be successful. Next, I will verify that hosts within the subnetted network can reach each other by pinging between PCA and PCC. Before, we weren't able to, but now let's see if PCA can be able to ping PCC, ping 172.16.30.3, and it is successful. And from PCC, if it can ping PCA, ping 172.16.10.3, and it is successful. Now I have this question. Now, why would we turn off automatic summarization for RIP version 2? So routers will no longer summarize routes at major classful network boundaries. And another question, how did router 1 and router 3 learn the pathway to the internet, which is represented here by this LAN here? they did from RIP routing updates received from the router where the default route was configured on router 2. Now, I hope you learned something from this simple lab. You will find everything if you go to the description of this video, the packet tracer source files for this topology, and download also the walkthrough documents. It will walk you step by step everything we did it in this lab with the explanation, and you will be able at the end, when you configure RIP on the routers and configure the static route on router 3, that the PCs will be able, after disabling the auto summarization or no auto summary, PCA here will be able to ping PCB, which represent the internet, and PCC will be able to ping PCB and PCA. Thank you so much for watching, and please, if you like this video, subscribe to my channel, and I'll see you soon in my next video. Have a nice day.